It's been a while, but we're back with another video from the new digital SAT practice test. This is the first practice test, but this is the non-adaptive paper and pencil version. So these questions can be... Hey, it's been a while, but we're back with another video on the digital SAT. This is from the practice test number 1 that they've released for the digital test, except this is not the digital version. This is like the non-adaptive paper and pencil version of that test, just so you know. So it looks like this, kind of like your traditional SAT, except this is the digital one for the new test. So on all these questions, we could use Desmos if we want. We can use a calculator on all of these, and we're going to see how quickly we can get to all 27, I think, answers. So the first one, Tilly earns P dollars for every W hours of work. Which expression represents the amount of money in dollars that Tilly earns for 39 W hours of work? So this one's a little bit tricky for a first one, at least it's confusing with all the letters, but basically let's say that P is 10 bucks for every hour. So if W is 1 hour, $10. Well, if she works or he works 39 W hours, so 39 times 1 would be 39 hours. We would just scale that up and multiply 39 by 10. Okay, so it would be 39 times P. All right, did you see what we did there? So 39 times 10, $390 is what Tilly would earn for that many hours. Okay, so that would be A. What about the second one? Juan rides his bike, average rate of 5.7 minutes per mile. Which function M models the number of minutes it will take him to ride X miles at this rate? Another one that's kind of tricky for an early on problem. But he rides, let's see, 5.7 minutes. Every 1 mile is what per mile means. So 1 mile equals 5.7 minutes, we could say. So it says X miles is what we're trying to figure out. Well, if he goes 2 miles, that would just double. It would be in 11.4 minutes, right? And you should see what's going on here. We're taking the number of miles, X, and we're just multiplying it by 5.7. So 5.7 times 2 is this. If he was going to go 3 miles, X was 3. It would triple that, so it would be like 16.1 or something like that, or 17.1, whatever the heck it would be. Okay, but you get the idea. We're going to multiply. That would be 5.7 times X, so we get D. The third one, this is the first one where we can use Desmos. It's a system of equations. I'm just going to start by typing it in, and I'll put it in exactly as I see it, and we can see that the intersection point, which is the solution, is 4, 6, but they want the y value, so it would be positive 6, b. 4, here is an equation that gives the speed s of a certain car t seconds after it begins to accelerate. So what's the speed? In other words, what's the s value when we're 5 seconds after starting to accelerate? Well, that's the t value, so t is 5. We just plug 5 in for t here. So it's just going to end up being, if I clear this out, I could even do it in Desmos. 40 plus 3 times 5, 55. And we get an answer of D. This next question is a right triangle, so we could use the Pythagorean theorem. It says which expression represents the value of C. So A is 4, B is 5. We can write those into here. And we get, well, A squared plus B squared equals C squared. We need to find C, so this gives us 4 squared plus 5 squared equals C squared. And if we want to solve for C, we can square root both sides, and we don't even have to do these out over here, because when we take the square root of C squared, we're going to get C equals the square root of 4 squared plus 5 squared, and notice that that is an answer, so we get D. How about number 6? The solution to the given equation. This is an example of one that we can do out pretty easily, but we can also use Desmos to solve equations. So 4x plus 5 equals 165. We'll just type it in like that. And I don't see anything on the graph, but it's because the answer is a little bigger. If you scroll over or you just zoom it out, you'll see that this vertical line here goes through 40. And so the x value of the answer would be 40. So that would be what we get for this answer here, 40. So anytime there's an equation, you can use Desmos to solve it. About number 7, the x-intercept is x comma 0. What's the value of x? Well, that's easy, because the x-intercept is where it crosses the x-axis, and obviously that point is 7. Moving on, number 8, what's the y-intercept of this graph? Well, we can do it out pretty easily. You might know how to do it, but I want to show you that you can also use Desmos. So f of x equals 1/10 x minus 2. We could zoom it in or hit the home button to zoom it in a little bit better. And they want the y-intercept. Click on the y-intercept, which is where it crosses the y-axis, and there's your answer. 0, -2, and we get B. About number 9. The function f is 7x cubed. They say that g of x is the result of shifting f of x down 2. Which equation defines g? Okay, so a couple ways that we could do it. We could first type in f of x into Desmos the way that we see it, 7x cubed, and they want g to be a shift of down 2. So the easy way is just to recognize that a shift of down 2 would just be to put -2 at the end, so D is going to be the answer. If you didn't know that, you could plug in at this point into Desmos all of these options and see which graph is the shifted down 2 version of the original function. So if you were to type in D, which is 7x cubed minus 2, and you just zoom it in, you could see that all they did to get that was to take the green function, which is f, and shift it down 2 spots. Okay, if you typed in 7/2 x cubed or this one, none of them would be the same. Okay, that's another way that you could find that D is the answer. Okay, how about number 10? What ordered pair is a solution to this system? So this should be one that we can do pretty easily in Desmos. We'll just type it in as we see it, and I'll tell you what to look for in a second. There we go. So if we zoom it out, the solution to a system is the intersection point. So if you scroll this up now, the red and the black graphs are going to intersect there, and that would be the solution. So how easy, right? And that gives us an answer of course, A. Number 11, which expression is equivalent to this one? Well, this is simple because we're going to have 7x cubed minus 6x cubed, which is just 1x cubed, which is the same as x cubed. And then we also have over here the x's we can combine. So 7x minus -3x, that's a double negative. We have to add it. So 7x plus 3x is positive 10x, and that's our answer. We get A. What about 12? P of n equals 7n cubed. So what's the value of n when P of n is equal to 56? Well, if P of n is 56, let's plug 56 in for P of n. So we get 56 equals 7n cubed, and they want the value of n. So we can solve this for n, and now that this is just a simple equation, we can actually use Desmos. So I'm going to type this in just like I see it, except I'm going to use x instead of n because Desmos doesn't like variables other than x and y. And the answer, as we saw before, is just where this crosses the x-axis. So if I zoom in it a little bit, it's hard to tell. It's not letting me click, but it should be obvious that if this is 0 and this is 5, this is the x value of 2. Okay, so the n value, because we plugged in x instead of n, the n value would just be 2. What about 13? So these lines are parallel, and they want to know x. Well, remember, with parallel lines, if this is 110, the one right next to it, because these two angles make up a straight line, 180 degrees, that one would have to be 70, because 110 and 70 makes 180. And if this one's 70, this one must also be 70. We call those angles corresponding angles. They're kind of in like the same position as each other. And you can see that whatever this one is, looks like these are exactly the same, and that's true. So x must be 70. What about 14? The mean of these data, that's the average, and Desmos can find the average really easily. We just type, I think is it mean? Yeah, there we go. So type in mean, and then put parentheses, and in the parentheses just type the list, 6, 8, 16, etc., etc. And as long as you don't make a mistake, then Desmos will tell you the answer. So there's all the numbers. The mean we see there is 10. Nice and easy. 15. What does this 5 represent in the context of this problem? So it says that this equation gives the estimated number of employees at a restaurant. T is the number of years since the restaurant opened. What would 5 be? Well, if we know exponential functions, we might know that the number in the front is kind of like the initial value, the starting amount, and that's true here as well. And so if t was 0, right, if we plug 0 in for t, so if t is equal to 0, that means that the number of years is 0. That basically means the restaurant hasn't opened yet, or it's just at the very beginning of opening, right? It's just opened. How many employees would there be? Well, anything to the 0 power, remember if we plug in 0, 1.8 to the 0 is just 1. So we end up getting 5 times 1, which of course is just 5. So that means that the number of employees was 5 when the restaurant first opened. And that's the answer we're looking for. And so that would be in A. The estimated number of employees when the restaurant opened was what that 5 represents. Okay, so always think about plugging in 0 as the exponent in these problems, because that's going to allow you to figure out what they're looking for. What about 16? What's the minimum value of the function? Well, we can go to Desmos. I'll click the home button to go back to the regular Zoom, and I can put in the function just as I see it there. And notice that it jumped up here. So the minimum value is just that low point there, the vertex. The minimum is at 55. It's not 0. 0 is the x value, but the minimum refers to like the height, the y value, and the minimum would therefore be 55, which is B. Number 17, each year the value of an investment increases by 0.49% of its value the previous year. So which of these functions is it? Well, obviously it's increasing because they literally say it increases. So how could it be decreasing? We'll get rid of A and B. And if it increases by a percentage of its value, that means it's going to be exponential. That's a key language for knowing that it's increasing exponentially because it's going up by a percentage, and so we get C. How about number 18, another percent problem? The population of Greenville increased by 7% if the 2016 population, so it increased by 7% from 2015 to 2016. So that new population in 2016, it's K times the 2015 population. What's the value of K? So if something increases by 7%, that means that we can multiply it by a certain number. That's what they're looking for. So we can do this a couple ways, but the easy way is just to know that if I go up by 7%, well, the new amount is going to be 100% of the old amount, right? The same as the old amount, 100% of it, plus 7 more. That's an increase of 7% for a total of 107%. And we can convert this to a decimal by either dividing this by 100, because percents are always over 100, or we can move the decimal 2 places to the right, or sorry, to the left. Either way, we'll get 1.07. So that would be the answer. Another way you could do it is you could pick 2 numbers. You could say, what if the population in 2015 was 1,000? Well, to go up by 7%, you can go to Desmos, and you could say, well, let's see, what's 7% of, notice in Desmos, if I just type 7%, it automatically says 7% of, and I could say 7% of 1,000, the number that we started at. Well, that number would be 70, and so if we increase by 7%, our new population is going to be 1,070. So the question is, what did I multiply 1,000 by to get to 1,070? You could also set up an equation that looks like this. 1,000 times something equals 1,070. What would that number be? Oh, look, it tells us 1.07. So that's another way that we can do this one. Either way, we get C. How about 19? Which expression is equivalent to A to the 11/12? Well, you could, if you know your rules for exponents, you could recognize that this is really the 12th root of A to the 11th, right? If you think back to like square roots, A to the 1/2 is equal to the square root of A. This is really a 2. This is really a 1. So that's how I was able to write this. But that's not an answer. So which of these is equivalent to that? Well, we need to do a little thinking now. So if we look at A, there's no way that the 12th root of A to the 132nd power is equal to the 12th root of A to the 11th, because these are the same, so these have to be the same, and that doesn't work. So A is definitely out. But if you look at B, that could work because it looks like they took 12 and they multiplied it by something to get to 144. Well, 12 times 12 is 144. So if they took 11 and also multiplied it by 12, do you get 132? You sure do. So it seems like that's going to be the answer. So basically, we looked for the one that matched this by figuring out, oh, they just multiplied each of these two numbers by the same number, 12. So that would be an answer of B. What about number 20? Event planners planning a party. It costs a one-time fee of $35 to rent the venue, and then it's $10.25 per attendee. The planner has a budget of $200. So what's the greatest number of attendees possible without exceeding the budget? So we could set up an inequality or an equation here. We could say it's $35 one-time fee plus it's $10.25 for every attendee. So if a number of attendees is, let's say, X, we could do 10.25 times however many attendees, so times X, and that has to be less than or equal to 200. That's their budget. And we should be able to just put this into Desmos. So let's see if we can solve it using this calculator. Less than or equal to, so you could type in shift and then the less than button, and then you could just hit equals right after it like that, 200, and so we could see this nice shaded area, and the maximum amount is this X value here, 16.098. So that's technically the answer, but of course we can't have a decimal number of attendees. You can't split a person in half. And so the answer, we would just round it down to 16, right? If we went up to 17, that's going to exceed the budget, so we'll stay down at 16, and 16 would be the final answer. Number 21, we've got an absolute value equation. They say, what's the positive value of x minus 1? So I think we can do this in Desmos. I haven't played around with this one yet, but if we want to do an absolute value, the button is shift and then the button right under backspace or delete, and it's right above like the enter or the return button. So we get 4x minus 4, close that absolute value, equals 112. Okay, great. So this shows us that there's two solutions. We've got a negative answer and a positive answer. And I hope that I can zoom in and see what that positive answer is, because they want the positive value of x minus 1. So the positive solution to that equation is the one we're looking for. And it should be hopefully obvious. I don't know why Desmos doesn't show these sometimes, but this is 29. I think that that's clear. And so if x is 29, x minus 1 would be 29 minus 1, which is 28. So the answer for 21 is 28. Okay, now 22. We have a cube, an edge length of 68. That means all the sides are 68 inches. And a sphere with a radius of 34 inches is inside the cube, such that the sphere touches the center of each face of the cube. Yeah, that makes sense, because if the radius is 34, the diameter is 68, and so that would make sense that it would just barely touch every side. To the nearest cubic inch, what's the volume of the space in the cube not taken up by the sphere? So we're going to want to find the volume of the cube. I'll just say volume of the cube, and we're going to want to subtract from that the volume of the sphere, because that's going to tell us, whoops, I spelled it wrong. That's going to tell us how much space is not taken up by the sphere, right? We've got a cube. I'll try to just draw it really quickly. And then inside that, there's a, well, this is hard to draw, isn't it? There's a sphere, and it's touching all the sides of the cube. Okay, so hopefully that makes sense. Now, the nice thing about the SAT is that they give us these formulas, right? So let me go up here, and I'll write down both of the formulas. So we should know the volume of a cube. It's just the side cubed, right? The volume for a box is length times width times height, but it's a cube, so they're all the same, so it's just side cubed. This is the one that I have a hard time remembering. So let me copy that down to here, and we can just have that to look at. Okay, that's kind of a nice thing about doing it on here. Whoops. Is that I could just paste that formula in. Whoops. Whoopsie, whoopsie, whoops. There we go. So the volume of the cube is going to be side cubed, and the cube's side is 68. So 68 cubed. And from that, I'm going to subtract the volume of the sphere, which is 4/3 pi, and the radius was 34. So 34 cubed. And I could do this in Desmos. You can do it in your regular calculator. 68 cubed minus 4/3 pi times 34 cubed. And there we get 149,796 if we round up. And that would be the answer, A. 23. What's the diameter of the circle with this equation? This is easy to do in Desmos. Type it in just like you see it. And let me just make sure I got it right. Looks good to me. Go to home. Oh, perfect. There's the circle. Now, what's the diameter of that circle? It's the distance from one end all the way to the other through the center. So if you look at these 2 points, if we find their distance, that's going to be our diameter. Well, how far is it from 5,7 to 5-1? You probably recognize that the x values are exactly the same, but the y values are the ones that we're going to look at. So from 7 to -1, what's that distance? That'll give us our answer. That distance is 8. If you didn't know that, I think you can do the distance formula in here, or the distance between the points. 5,7 and 5-1. I think you could go like this. 5,7 is the first point, comma, 5-1. Perfect. There, it does it. So if you didn't know how to do it, you could do that. And the answer, the distance is 8. That would be our diameter of that circle. 24. For an exponential function, f of 1, the value of f of 1 is k, or k is a constant. Which of the following equivalent forms of the function f shows the value of k as the coefficient or the base? I'm going to say that I'm a little bit confused on this one, so don't worry if you are as well. Let's think about it for a second. Okay, so if it says f of 1, this value 1 is the x value, right? That's the number we plugged into the function. So if we take 1 and we plug it into each of these answers, that's going to give us some information. All right, if we plug 1 into here, it's going to be 1.6 to the second power. So 50 times 1.6 to the second power. This is going to be really, really messy. That's unlikely to be the answer. I'll explain why in a second. What about B? The same thing's kind of going to happen here. It's going to be 80 times 1.6 to the first power. But C is really, really nice because we end up getting 1.6 to the 1 minus 1 power, right? If we plug in 1, we're going to get 0 as the exponent. 1.6 to the 0 is 1. So this is just going to simplify to be 128. And that's it. And so that turns out to be our k value that we were looking at, where k is the coefficient, in the front of that equation. Okay, so this turns out to be the answer. Basically, the way I knew that that was right is it turned out nice and clean. It simplified very nicely. And remember, we were looking for k to be a constant where it was either the coefficient or the base. And sure enough, this is the k value 128. That is right in front here. All of these other ones, if you work them out, are going to give you messy decimals, and none of those decimals show up in the equation itself. So that's essentially what they're looking for. So we get C. What about 25? So the number of squirrels goes up by 150% between this year and this year. And it says at the end of 2016, there were 180 squirrels in the population. So which of these is going to represent that? Let's try to figure it out. The first thing to notice is that if it's increasing by 150%, it's 150% more. We did one like this a couple questions ago where we take 100% of the old number, but we're increasing it by 150% for a total of 250%, which corresponds to a decimal of 2.5. So that's why the answer has to be either B or D, because those are the only two that have that increase of, or the 2.5 in the parentheses that we're looking for. Okay, that's the first thing. Now, which of these is going to give us an answer of 180 squirrels? Well, If we are looking for that number of squirrels at the end of 2016, remember that t is the number of years since 2015. So 2016 would be a t-value of 1. It's 1 year later. So the question is, if t is 1, which of these two equations gives us a population of squirrels of 180? So B would be, well, we can figure it out. Let's go over to Desmos and just type in 72 times 2.5. And remember we said t was 1. And look, that gives us our squirrel population of 180. If we tried that same thing with D, it's not going to work. I'll show you why. If we raise that to the first power, that's the wrong population. We know it should be 180. Okay, so after all that, we find out that the answer should be B. All right, we've only got a couple questions left, and they look like this. So 26, messy system of equations. Which of the following pairs of equations, oh, okay, they say that this set of equations is perpendicular. So which of the following is also perpendicular is what they say. Well, the first one is simple. 5x plus 7y is equal to 1. So if we go to that equation, we could see that it has a certain slope and everything, which we could find if we want. But what would we have to make a and b in order for them to be, as they say, perpendicular? Well, let's play around with some numbers. If we remember from learning about parallel perpendicular lines have opposite reciprocal slopes. And so it turns out that the coefficients for this next equation, a and b, are going to be some variation of 5 and 7. So let's just play around with it and see. What if we try negative 5x plus 7y equals 1? They're close, but you could probably tell that they're not quite 90 degrees. Maybe if we try positive 5, oops, nope, that's actually the same equation. Those are clearly parallel. They're actually the same line. But what if we make 7 negative? That doesn't work either. What if we make them both negative? That doesn't work either. So maybe we could try making the x coefficient 7 and the y coefficient 5. Let's try that. Make this one 7, maybe make this negative 5. And, whoa, guess what? Those lines look 90 degrees. So that means that the a value, remember a was the coefficient of x, a has to be 7, we just found, and b must be negative 5. So now we're going to take those same coefficients and plug them into each of the answers and see which one also is perpendicular. Okay, so let's go to Desmos and clear out those. We found what we needed from it. And let's type in the first answer, a. 10x plus 7y equals 1. And then a is 7, so we get 7x minus 2 times negative 5. So that would end up being plus 10y equals 1. Question is, are those perpendicular? Clearly not, so A is wrong. And unfortunately, I think, at least right now, I think the best way to do it is just to keep typing in each of the answers and testing it. Turns out that these were the same equation, so I could have probably left the first one there, but now I know. AX with 7x plus 2by, so 2 times negative 5 would be negative 10y equals 1. Ooh, look, those are perpendicular. Okay, and you could even tell just by looking at the slopes, this is negative, it's a negative reciprocal, right? If you were to solve out the first one, you could solve it for y, and this would give you y equals negative 10/7 x plus 1/7, right? And then the second one, actually this second one, if we solve that for y, we're going to get y equals negative 7 over negative 10x minus 1/10. This is what we care about. That is 7/10, which is the opposite reciprocal of negative 10/7. So that's why these are perpendicular, and the answer is B. And then finally, 27, they say that this, so C is a constant. The equation has no real solutions if C is greater than a certain number, n. What's the least possible value of n? Well, let's see. X squared minus 34x plus C equals 0. Now, the problem is that we need this to be, it says we only support implicit equations of x and y. So what we'll do here is instead of it saying equals 0, let's say y equals that. Okay, Desmos is, for whatever reason, happier with that setup. Now it says we can add a slider. So let's hit that C button, and we could see that if C is 1, the graph looks like this, if we zoom it out. And if we keep changing C, you could see that maybe you could tell that the graph is kind of starting to move, but we need way bigger values of C. Okay, so let me just change the range of C to maybe -100 to +100, and let's see what happens. Now, as I make C bigger, the graph is getting higher and higher, but what are we going to look for? We want no real solutions, aka no intercepts, no x-intercepts. So we want C to keep getting bigger so that this graph eventually rises above the x-axis. So let's change this to maybe go up to, I don't know, 200, and let's see if that helps us. Oh, it's getting closer, but we need to get bigger and bigger. Okay, so if I go even bigger, I'll maybe make this just 200 to 300, and let's keep making it bigger, 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 bigger. We're getting there, boom. Okay, so at 289, it just touches the x-axis, but that still counts as a solution. So if n was exactly 289, if n, let's write it down, if n is equal to 289, remember, C is bigger than n. So if C is greater than 289, maybe it's 289 like 0.1, look, it rises above and has no solution. So as long as C is greater than 289, even if it's 289.1 or 0.01, that's going to be our answer. So n, the least possible value of n, is 289. And that's that. So that's the end of the test. Hopefully that's helpful. Like this video, share it. Let us know in the comments if there's any questions that maybe we made a mistake on, or if you think you could do a little bit faster. Share so that everybody can know the faster way to do it. But remember, use Desmos as much as you can, and best of luck to you as you study.